Alrighty, so correlation versus causality. As in correlation, how well things are related, versus causality, whether things are actually being caused by that or not. So, what I want to say is that correlation, how things are related, does not necessarily, like a good correlation, does not necessarily imply that causality, or whether something is actually happening. So, causality is whether the dependent variable is being caused by the independent variable, or it's just being caused by something else in particular. So let me give you an example. They did a study on primary school students, and that suggested that as your shoe size increases, if you've got a bigger shoe size, then you're smarter. You have a higher IQ. So no matter what, you got a bigger. They did all the data, and there was a strong R squared value, strong correlation in the R value, and they said that if you've got bigger feet or bigger shoe size, you're a smarter person. That sounds ridiculous. In fact, it is ridiculous. So the correlation was high. So doesn't that mean that they're closely related, which we talked about? Well, it means that the two results were closely related, but it doesn't necessarily imply that shoe size is actually related to your intelligence. Really, if you think logically, if you're studying primary school students, isn't it just that if they surveyed kids from prep to year 6, the year 6s are going to have bigger shoe sizes than the preps, and the year 6s are going to be smarter. So obviously for their survey, as people's shoe size got bigger, of course they're getting smarter because they're getting older, and the real cause is their age is affecting their IQ. It's got nothing at all to do with their shoe size. It just happens that their shoe size fits in that data as well. So we have to think about the causality, or the cause of that data to look closely related, rather than just the two raw pieces of information. Another example, for instance, you could say that in summer, ice cream sales peaked really high, and also in summer, shark attacks peaked really high. So doesn't that mean that ice cream sales means more shark attacks? So if you're eating ice cream, you're more likely to get attacked by a shark. Of course not, that's stupid. Like, sharks and ice cream have nothing to do with each other. But when we look at the causality of that, what's causing that is in summer it's hotter and more people are buying ice creams because it's hotter, and because it's summer more people are going to the beach and more people are being killed by sharks each year. So we can't just say that because there's a strong correlation between ice cream sales and shark attacks, that ice cream sales are causing shark attacks. That's ridiculous. Instead, we have to think about the causality, what is causing that, and suggest that they're not actually related, even though the data suggests that there is a strong relationship. So the basic premise is, if they're strongly related, are they actually related to each other or not? Are they actually causing each other, or is it just chance that those two pieces of data can look like they're strongly related?